Basic Skills, Day 8, Solving Equations. So we're going to start working on solving equations, and today we're going to work on kind of simple equations that just involve one or two steps. Then we're going to get into more challenging equations where there are multi-steps. So here's a problem that you could set up an equation to solve. I know a lot of you would just be able to solve it intuitively, but let's just see what it says. It says you and a friend go to a football game and purchase food at a concession stand. You purchase 2 slices of pizza and a Gatorade, and your friend purchases 3 slices of pizza and a candy bar. You both end up paying $6. How much did each slice of pizza cost if the Gatorade costs $2.50 and the candy bar costs 75 cents? Well, what you could do is take a look at even just the first person that had 2 pieces of pizza plus a Gatorade, and that was equal to $6. Or we could look at the other person who bought 3 pieces of pizza plus a candy bar and also spent $6. So we really just need to solve this, either one of them. We know that the Gatorade costs $2.50. So 2 pieces of pizza plus $2.50 is equal to $6. So now what I'm going to do is take away the Gatorade from the $6. So if I subtract the $2.50 from the $6, that is going to give me 2 pizzas cost $3.50. That's the money that you spent on just the pizza. So now if we just go ahead and divide that by 2, that would give us the cost of the pizza is $1.75. And that's what we're really doing when we're solving this equation. And you could solve the other person's and you would get the same thing. So we are going to solve 2 or 3-step equations, and we have a homework worksheet again, Day 8, Solving Equations worksheet number 1. So how do we find the solutions to one-variable equations? To find the solutions, the variable must be what we called isolated. So our goal is always to isolate the variable, which means we get it by itself. So we get the variable by itself. So a variable is isolated when it appears alone on one side of the equation. When moving variables and constants around, the equation must stay balanced. Therefore, if a certain amount is taken away or added to one side, then the other side must get the same treatment. So basically, whatever we do to one side of the equation, we have to do to the other. This makes it stay equal. Kind of like a balancing scale, okay? If you add 2 pounds to each side, it'll still stay balanced. If you subtract 8 pounds from each side, it'll still stay balanced. And to do that, what we like to do is do the opposite of what was done to X. And that helps us undo it. So if you look at the example we have above, in the first example it's crossed out because we subtracted 8 and then we subtracted 6. That's not the same amount, and that's why that is not correct. You have to subtract the same amount. And again, another way to look at this is you have X and you added 8 right here to it. So to undo adding 8, what we do is we subtract 8 from each side. That undoes adding 8. That's what I mean by undo what was done to x. And so we get our answer that x is equal to 4. So how do we know if that's actually the correct answer? Well, to check if an answer is correct, all we need to do is plug that number or answer back into the original equation and see if it satisfies the relationship or makes it true. So, for example, when x equals 3, x plus 3 equals 6 is true, because when we plug in 3 for x, that's a true statement. But x plus 2 equals 7 is not. In other words, if we put 3 in here, that is not true. So that's what we're talking about. When we want to check to see if we have the answer correct, we plug in the value for x right here and make sure that it is a true statement. That's how we know that that is the solution. So, specifically, when we are solving two and multi-step equations, again, our main goal is to isolate the variable. So we manipulate all the constants to one side. That's the plain old numbers. And we make the coefficient, which is the number in front of the variable, 1. So we need to make the coefficient 1. So in this case, what we have here is we have 2x plus 3 equals 13. So the first thing we have to do, again, our goal right here is to get x by itself. What was done to x? Well, we multiplied by 2 and then we added 3. So the first thing we have to undo is adding 3, which is subtract 3 from each side. Then that cancels out, and we get 2x equals, and then 13 minus 3 is 10. So now here's where we talk about we need to get this coefficient in front of x to be 1. So again, this was x times 2, so I'm going to do the opposite, which is divide each side by 2. And when I divide each side by 2, now I get that x, again, this cancels out. 2 divided by 2 is 1, so now I have 1x equals 5, or simply x equals 5. So I know this is stuff that you've done before, so let's work through a few of these examples. I would like you to try example 1 and 2, and then start the video back up and see if you got them correct. The first example should give you x is equal to 9/4, and we can leave that just like a fraction. Now, if you didn't get that correct, follow along and listen and watch. But what we have to do is we have to subtract 3 from each side. That cancels that out, and we get 9 is equal to 4x. Then we have to divide each side by 4, and that gives us x equals 9/4. Because again, 4 divided by 4 gives us our 1x. And we don't need that 1 in front. I'm just putting it in there right now so that you can see. In the second example, what you should have gotten for the correct answer is that x is equal to 72. So again, if you didn't get this correct, let's look at what we need to do. We need to get x by itself. So the first thing we need to do is undo subtracting 8 by adding 8. That gives us 1/4 x is equal to 18. So again, look at this for a minute. We have 1/4 times x right here. So we have to divide by 1/4. Anything divided by itself is 1. So now what we have is we have to take 18 and divide it by 1/4. And with our work with fractions, we know then that that is going to become 18 over 1 times the reciprocal, keep, change, flip. So now we get x is equal to 18 times 4, which is x is equal to 72 over 1, or x is equal to 72. Okay, here's 2 more. So try these 2 examples. This should have a number 3 in front, but go ahead, try these 2, and then pause the video and see if you got them correct. Okay, let's work through this. Again, just like that last example, we have to subtract 4 from each side. So now we get 2/3 x is equal to 1/2 minus 4, which is -3 1/2. Now I'm going to need to change this to an improper. So 2 times 3 is 6 plus 1. That gives me 7/2, but it's negative, is equal to 2/3 times x. Here's where I have to divide each side by 2/3. So I have to divide by 2/3. So what's going to happen is I'm going to end up with -7/2 divided by 2/3. But remember, dividing fractions, we have to keep, change, flip. So now I have -7/2 times 3/2. I multiply straight across, which gives me -21/4. And so that is what x is equal to. In the second example, the first thing we do is we simplify the 3 minus 5 to get -2. So now I have 2x minus 2 equals 4. Now I'm going to add 2 to each side to undo subtracting 2. My goal is to get x by itself, isolated. Now I have 2 times x, so I do the opposite and divide by 2, and I get x equals 3. Remember, we can always check our answer by plugging it back into the equation. So if I want to make sure that this is the correct answer, I go ahead and take 2 and put in my x value of 3 in for x. So 2 times 3 plus 3 minus 5 is supposed to equal 4. Well, 2 times 3 is 6. 6 plus 3 is 9. So 9 minus 5 is 4. I get 4 equals 4. So that is the end of our Day 8 basic skills.